Ever wondered why Amish furniture serves families for 100 plus years while IKEA furniture collapses within 5 years? It's not magic or luck, but superior materials, hand-cut joinery, and engineering that modern manufacturing abandoned for profit. An $800 Amish table lasts 20 times longer than a $400 IKEA table, making it 4 times cheaper over its lifetime. This is traditional craftsmanship, creating furniture that becomes family heirlooms rather than landfill waste. Real solid wood. The fundamental difference between Amish and IKEA furniture begins with the material. Amish use solid hardwood lumber throughout every piece, while IKEA uses particle board, MDF, and thin plywood veneered with paper-thin real wood or plastic film printed to look like wood. The Amish wood selection starts with species chosen for strength, durability, and beauty. Quarter-sawn white oak, hard maple, black cherry, and black walnut being the most common. Quarter-sawn means the log is cut radially rather than tangentially, producing boards with vertical grain patterns that are 30 to 40% stronger than plain sawn lumber and far more resistant to warping, cupping, and twisting over decades of humidity changes. The lumber thickness is substantial 4/4 to 8/4 stock, meaning actual thickness of 1 inch to 2 inches after milling and surfacing. A table leg might be 3 inches by 3 inches of solid oak. A dresser side might be 3/4 inch solid maple, and a chair seat might be 1.5 inches solid cherry. This is actual dimensional lumber, not nominal dimensions that shrink during processing. A 3 by 3 leg measures 3 full inches on each side. The wood is air-dried for 18 to 24 months after milling, slowly reducing moisture content from 30 to 50% green wood to 6 to 8% equilibrium moisture content, matching the environment where furniture will live. This slow drying prevents the rapid shrinkage, cracking, and warping that occurs when keyline dried lumber is forced to dry in days rather than years. The investment in time, 2 years from tree to furniture, cannot be replicated by manufacturers needing inventory turnover measured in weeks. The cost of this solid hardwood is substantial. $200 to $400 in raw lumber for a dining table, $300 to $600 for a dresser, $50 to $100 for a chair. These material costs alone exceed the total retail price of comparable IKEA furniture, explaining immediately why modern manufacturers cannot use solid wood and remain price competitive. IKEA furniture uses particle board wood chips and sawdust compressed with adhesive, costing $5 to $10 per 4x8 sheet compared to $150 to $300 for equivalent coverage in solid. Hardwood. The particle board is covered with thin veneer, real wood, shaved to 1/16 inch or thinner, or melamine film printed with wood grain pattern, creating an appearance of wood furniture while using almost no actual wood. The engineering difference is profound. Solid wood gains strength as it dries and ages, the cellular structure becoming denser and more rigid over years and decades. The wood can be refinished 10 to 15 times over a century by sanding away the damaged surface and applying new finish, essentially renewing the piece indefinitely. Solid wood damaged by impacts or wear can be repaired by gluing, clamping, and refinishing, restoring full strength. Particle board and MDF deteriorate from the moment of manufacture. The adhesives holding wood particles together break down from humidity, cycling, temperature changes, and UV exposure. The material swells when wet and never fully recovers its original dimensions and strength. Once the thin veneer is damaged, scratched, chipped, or delaminated, the particle board beneath cannot be refinished because sanding would remove the veneer entirely, exposing the ugly compressed chip material. When particle board joints fail, the fasteners pull out of the crumbly material with no possibility of creating strong repairs. The furniture becomes garbage. Hand-cut joinery. The connections between furniture components determine whether the piece lasts 5 years or 100 years, and Amish furniture uses traditional mortise and tenon and dovetail joinery hand-cut by skilled craftsmen, while IKEA uses camlocks, dowels, and staples that fail rapidly under normal use. The mortise and tenon joint is the foundation of Amish furniture construction. A projecting tenon on one piece fits precisely into a mortise, rectangular hole cut into another piece, creating wood-to-wood contact over 10 to 20 square inches of surface area. The joints are cut entirely by hand using chisels, saws, and shoulder planes, requiring hours of careful work to achieve the precision necessary for proper fit. The fit tolerance is critical. The tenon should require moderate hand pressure to fully seat into the mortise, tight enough to create friction holding the joint together even without glue, but not so tight that forcing it splits the mortise walls. This precision comes from craftsmen who've cut thousands of joints over decades of practice, developing the feel and judgment that cannot be taught from books or videos. The joints are secured with wooden pegs, typically 3/4 inch to 1 inch diameter oak or hickory dowels driven through holes drilled perpendicular to the joint, passing through both mortise and tenon and locking them permanently together. The pegs themselves swell slightly when absorbing moisture and shrink when drying, creating self-tightening effect that maintains joint integrity through seasonal humidity changes that would loosen, glued, or fasten joints. The glue used is hide glue or modern wood glue applied as backup reinforcement, not as primary joint strength. The wood-to-wood fit and the pegs provide the structural strength, while glue fills microscopic gaps and adds some additional adhesion. This philosophy differs fundamentally from modern furniture, relying entirely on glue or mechanical fasteners without proper joint geometry. When the glue fails or fasteners loosen, modern furniture collapses while traditional joinery remains solid. The strength is extraordinary. A properly cut mortise and tenon joint is stronger than the wood itself. Stress testing shows the wood fibers failing before the joint separates. This over-engineering means furniture can be abused, stressed, and used hard for decades without joint failure. Chairs can be tipped back on two legs, tables can be sat on, dressers can be moved repeatedly. The joints handle this abuse without loosening. IKEA furniture uses cam locks, circular plastic, or metal discs that rotate to draw pieces together, creating initial tightness that feels solid but loosens rapidly with use. The cam locks rely on particle board or thin plywood holding threads and compression, but the soft materials compress under stress and the fasteners loosen within months or years. Tightening the cam locks damages the particle board further, stripping out material until the fasteners no longer grip at all. The dowels IKEA uses in some pieces are glued into pre-drilled holes without the precision fit and load-bearing geometry of traditional joinery. The dowels concentrate stress at small points rather than distributing load across large joint surfaces, creating failure points that crack the wood or particle board with repeated stress. The staples holding backs, bottoms, and minor components pull out of particle board with minimal force, particularly after humidity swelling has weakened the material. The staples provide no structural strength, serving only to hold thin panels in approximate position until the first significant stress pulls them loose. Dovetail drawer construction. Drawers receive the most intensive repeated stress of any furniture component, pulled open and pushed closed thousands of times per year, loaded with varying weights and subjected to racking forces that test joint strength, making drawer construction the clearest indicator of furniture quality and longevity. Amish drawers use through dovetail joints featuring interlocking pins and tails hand-cut with precision that creates both visual beauty and structural superiority. A typical drawer has 12 to 16 individual dovetails per corner. 4 corners means 48 to 64 individual dovetails per drawer, each cut individually by hand using dovetail saws and chisels. The geometry is engineered perfectly. The tails, the wider trapezoidal projections, angle at approximately 8 degrees steep enough to create mechanical locking, preventing the joint from pulling apart, but not so steep that wood shrinkage causes splitting. The pins, the narrower trapezoidal projections, fitting between tails, are sized to provide maximum glue surface while maintaining wood strength, preventing breakage. The drawer sides are solid 3/4 inch oak or maple, providing the mass and strength necessary to support the dovetail geometry. The joints distribute stress across the entire side height rather than concentrating force at a few screws or staples. When a loaded drawer is pulled, the force is transmitted through all 12 to 16 dovetails simultaneously, each bearing a fraction of the total load. This load distribution means no single point experiences stress sufficient to cause failure. The drawer bottom is solid 1/2 inch wood, typically pine or poplar for cost economy, since it's hidden floating in grooves cut into the drawer sides. The bottom isn't glued or fastened, but slides into grooves and is free to expand and contract with humidity changes without creating stress that would crack a glued-in bottom. This floating panel design has been used for centuries because it accommodates wood movement that modern rigid construction cannot handle. The drawer slides are wooden runners, hardwood strips attached to drawer sides that slide in corresponding grooves in the cabinet case. The wood-on-wood contact is smooth when properly fitted and waxed, requiring no maintenance and lasting indefinitely. Some modern Amish pieces use quality ball-bearing drawer slides rated for 100,000 cycles and 100-pound loads, but traditional wooden runners remain common and preferred for authenticity. The result is drawers that operate smoothly after 100 years of daily use. Antique Amish dressers from the 1920s and 1930s, now 90 to 100 years old, still have drawers that slide perfectly, dovetails still tight, and no repairs needed. The drawers might be refinished or the wooden runners might be replaced once in a century, but the fundamental structure remains sound and functional. IKEA drawers use thin plywood or particle board sides, often 3/8 inch or even thinner, connected at corners with staples, small nails, or plastic snap-together joints. The drawer bottom is 1/8 inch hardboard or thin plywood stapled to the bottom edges. The entire drawer weighs a fraction of the Amish drawer and costs perhaps $5 to $10 to manufacture, compared to $150 to $300 in materials and labor for the Amish dovetail drawer. The IKEA drawer slides on plastic or thin metal tracks that wear rapidly and often include plastic wheels that break within 2 to 3 years of normal use. The drawer sides flex and bow under load because the thin material cannot maintain rigidity, and the flexing accelerates the joint failure. Within 5 years, typical IKEA drawers have staples pulling loose, sides bowing outward, bottoms sagging, and slides failing, making the furniture unusable even if the exterior case remains intact. The repair comparison is stark. When Amish drawer joints loosen, perhaps after 75 to 100 years, the drawer can be disassembled, cleaned, reglued, and clamped, restoring essentially new condition. The solid wood sides can be refinished, the bottom can be replaced if needed, and the drawer continues serving for another several decades. IKEA drawers cannot be repaired, the thin material strips when staples are removed, the particle board crumbles when stressed, and attempting repair typically causes more damage than leaving it alone. The drawer, and often the entire piece, must be discarded. Multi-layer finishing. The surface finish protects wood from moisture, UV damage, physical wear, and aging while also enhancing the natural beauty of grain patterns and color. Amish furniture receives 6 to 8 hand-applied finish coats requiring 2 to 3 weeks of work, while IKEA veneer receives a single thin factory finish, providing minimal protection. The Amish finishing process begins with hand sanding, progressing through increasingly fine grits, starting at 80 or 120 grit to remove mill marks and tool marks, progressing to 150 grit for initial smoothing, then 180 grit to remove scratches from coarser grits, and finally 220 to 320 grit for the glass smooth surface necessary for proper finish, adhesion, and appearance. The sanding is done entirely by hand, following grain direction, with the craftsman feeling the surface constantly to identify any remaining roughness or imperfections requiring additional attention. Power sanders are generally avoided because they can create swirl marks or cross-grain scratches that become visible under finish. The hand sanding for a dining table might consume 6 to 8 hours. For a dresser, 8 to 12 hours time invested that modern manufacturing cannot afford. The first finish coat is typically a sanding sealer or thinned first coat that penetrates deeply into wood pores, hardening the surface fibers and creating foundation for subsequent coats. This coat is allowed to dry completely 12 to 24 hours, then is lightly sanded with 320 to 400 grit paper to remove raised grain and create smooth surface for the next coat. The primary finish coats numbering 5 to 7 use oil-based varnish, lacquer, or penetrating oil depending on the desired appearance and protection level. Each coat is applied by hand using brushes or cloths, working with the grain to achieve even coverage without drips or sags. Each coat must dry completely before the next is applied, and light sanding between coats ensures proper adhesion and removes any dust particles or imperfections that settle during drying. The final coat might be rubbed with fine steel wool and wax to create satin or matte appearance, or it might be left glossy depending on preference. The total thickness of finish is substantial, 15 to 20 mils, thousandths of an inch, compared to IKEA's 2 to 3 mils of finish on veneer. The penetrating nature of many traditional finishes means they don't just sit on the wood surface but actually soak into the cellular structure, protecting from the inside rather than just coating the outside. This penetration means the finish becomes essentially part of the wood rather than a separate layer that can chip or peel away. The refinishing capability is one of the finish system's greatest advantages. When the surface shows wear after 30 to 50 years of use scratches, worn areas in high contact zones, fading from UV exposure, the piece can be stripped to bare wood, resanded, and refinished to essentially new appearance. This process might cost $200 to $500 in professional refinishing, or can be done by the owner with time and effort, but it completely renews the piece for another 30 to 50 years of service. A single piece of Amish furniture can be refinished 10 to 15 times over its lifetime, each refinishing restoring full beauty and protection. IKEA furniture has veneer finish measured in mils, a clear coat perhaps 2 to 3 mils thick, protecting the paper-thin wood veneer or printed melamine film beneath. This finish cannot be sanded without immediately cutting through to the particle board substrate, making refinishing impossible. When the finish is scratched or damaged, the piece's appearance is permanently compromised with no repair option. The finish also doesn't penetrate into wood because there's no substantial wood present, it's just a protective coating over printed paper in most cases. Heavy-duty hardware. The hinges, drawer pulls, and other hardware components might seem like minor details, but they're critical to furniture function and longevity. Amish furniture uses solid brass or bronze hardware, installed with traditional techniques, while IKEA uses cheap zinc alloy that breaks within years. The hinges on Amish furniture are solid brass or bronze metals that don't rust, corrode, or degrade from normal humidity and use. The weight is substantial. A typical cabinet hinge weighs 3 to 6 ounces compared to IKEA's half-ounce to 1-ounce pot metal hinges. The brass hinges cost $30 to $80 per hinge versus IKEA's $2 to $5. But the cost difference buys hardware that functions perfectly for 50 to 100 years without replacement. The installation uses full mortise technique where the hinge leaf is recessed into the wood so it sits flush with the surface rather than proud of it. Creating these mortises requires hand-chiseling shallow depressions exactly matching the hinge dimensions, allowing the hinge to install without creating raised areas that would prevent doors from closing properly. This traditional installation takes 20 to 30 minutes per hinge versus 2 to 3 minutes for surface mounting IKEA hardware, but the result is superior strength and appearance. The hinge pintle, the pin, allowing rotational movement, is solid brass or stainless steel 1/8 to 3/16 inch diameter, providing wear resistance that keeps hinges operating smoothly for decades. The IKEA pot metal hinges use thin steel pins that wear rapidly from friction, creating slop and misalignment within a few years. The drawer pulls and knobs are similarly solid brass, bronze, or even hand-forged iron, weighing 2 to 4 ounces each and costing $15 to $40, versus IKEA's plastic or pot metal pulls weighing a fraction of an ounce and costing $1 to $3. The solid metal hardware maintains its appearance and function indefinitely, while IKEA hardware breaks, strips, or corrodes within 5 to 10 years. The drawer slides in modern Amish pieces using metal slides are high-quality ball-bearing units rated for 100,000 cycles and 100-pound load capacity, costing $30 to $60 per pair, versus IKEA's plastic or thin metal slides costing $3 to $8 and rated for perhaps 20,000 cycles with 50-pound loads. The quality slides operate smoothly and silently for decades, while cheap slides become sticky, noisy, and eventually fail completely. The long-term economic calculation favors quality hardware dramatically. A dresser with 6 drawers might have $80 to $120 in quality drawer slides versus $20 to $40 in cheap slides. The $60 to $80 premium buys slides that outlast 20 to 40 sets of IKEA slides that must be replaced every few years. Overbuilt structural design. Amish furniture is engineered with safety factors of 3 to 5 times expected loads, creating furniture that's essentially indestructible under normal use, while IKEA furniture is designed with minimal safety factors of 1.2 to 1.5 times expected loads, making failure almost inevitable over time. A dining table leg in Amish construction might be 3 inches by 3 inches of solid oak, 9 square inches of cross-section, when engineering calculations show that 1.5 inches by 1.5 inches would adequately support typical table loads. This 200% over-engineering provides massive safety margins, accommodating abuse, aging, and the unexpected stresses that furniture experiences over a century of use. The joints in an Amish chair are sized to handle 500 to 1,000 pounds of load, when typical use creates 150 to 300 pounds of force. This 3 to 5 times safety factor means the chair can be tipped back, jumped on by children, or used as a step stool without joint failure. The engineering margins are sufficient that even after decades of stress-induced microdamage, the joints retain double or triple the strength needed for normal use. The table aprons, the horizontal members connecting legs beneath the tabletop, might be 4 inches to 6 inches tall and 3/4 inch to 1 inch thick, when 3 inches tall and 3/4 inch thick would be structurally adequate. This oversizing provides stiffness, preventing the flexing and wobbling that develops in under-engineered furniture and creates mass that resists the racking forces trying to collapse rectangular tables into parallelograms. The design proportions follow rules developed over centuries of empirical testing. The ratio of leg thickness to table height, the spacing between legs relative to tabletop dimensions, the apron depth as a function of span. All of these relationships have optimal ranges that traditional craftsmen know intuitively from experience. The furniture looks right because it's proportioned right, and it's proportioned right because centuries of furniture making have proven what works. IKEA furniture is designed using computer analysis to identify the minimum material necessary to pass safety testing, typically requiring furniture to withstand loads 1.2 to 1.5 times the expected user weight or load. A chair might be designed to support 270 to 300 pounds when safety standards require 225 pounds, providing minimal margin for overweight users, multiple occupants, or abuse. The table legs might be 1.5 inches by 1.5 inches, 2.25 square inches cross-section compared to the Amish 9 square inches, providing 1/4 the cross-sectional area and 1/4 the bending resistance. The thin legs flex under load, creating wobbling that accelerates joint loosening. The legs are also typically softwood rather than hardwood, providing roughly half the strength even at equal dimensions. The minimalist engineering means that anything beyond normal, careful use creates stress-approaching design limits. Standing on an IKEA chair to reach a high shelf loads it to 200 pounds before accounting for the dynamic loading of climbing up, and any impact or uneven weight distribution can exceed design capacity, causing joint failure or even catastrophic collapse. Labor time investment. The construction time for Amish furniture measures in days or weeks per piece, with skilled craftsmen investing 40 to 80 hours of handwork creating each item, while IKEA furniture is machine-produced in 2 to 4 hours. and assembled by customers in 30 to 90 minutes. The time difference reflecting fundamentally different approaches to furniture creation. A dining table requires 40 to 60 hours of skilled handwork, including lumber selection and milling. 4 to 6 hours, mortise and tenon joinery for legs and aprons. 8 to 12 hours, tabletop glue up and flattening. 6 to 8 hours, fitting and assembly. 4 to 6 hours, sanding. 6 to 8 hours, and finishing. 12 to 18 hours. Each step demands skill and judgment that develop only through years of practice under master craftsmen. A dresser requires 60 to 80 hours, including case construction with traditional joinery. 20 to 30 hours. Drawer construction with hand-cut dovetails. 24 to 36 hours for 6 drawers at 4 to 6 hours each. Fitting drawer slides and hardware. 4 to 6 hours. Sanding. 8 to 12 hours. And finishing. 12 to 18 hours. The drawer construction alone exceeds the total time invested in manufacturing an entire IKEA dresser.